Hello, calculus students. This problem, we're going to use implicit differentiation to determine the horizontal and vertical tangent lines to this circle. Now, we could answer this question by finding the center of the circle and then determining what those points are geometrically. But in this problem, they ask us to do it using implicit differentiation, so we'll just follow the rules. All right, so first thing we're going to do is implicitly differentiate each side of this equation. Now, I am going to go through the implicit differentiation a little quickly. If you're still learning implicit differentiation, I'm going to recommend that you go to one of my other videos and check that out. This one, I'm just going to use it as a tool to solve this problem. Okay, so I'm going to push this derivative here through this left-hand side, and as I do that, I'm going to differentiate all the x terms just as you normally would using the power rule, and then I'm going to implicitly differentiate this y squared term, and we get 2y and dy dx because I implicitly differentiating. Then we differentiate the minus 10x, and we just simply get a minus 10 because we're differentiating with respect to x. And then we differentiate minus 8y, and there we get minus 8 dy dx. Okay, and then, let's see, that equals the derivative of minus 25. That's a constant, so that's equal to 0. Now, what we're going to do next is a little bit of algebra. And so we're going to solve for dy dx. So what I'm going to do is take this 2x and this minus 10, and I'm going to move them over to the right-hand side of the equation. So when I do that, I get a minus 2x and a plus 10 because they switch sign. So these terms are now gone. And then I'm going to factor out the dy dx, and we are left with a 2y and a minus 8. The 2y was next to this dy dx, which got factored out, and the minus 8, which is here, remains, and this dy dx gets factored out here. Alright, so now I just simply have to divide both sides by this 2y minus 8, and when we do, we have dy dx is equal to minus 2x plus 10 over 2y minus 8. Okay, so that is the derivative, and so now I'm looking for where we have horizontal and vertical tangent lines, and we have horizontal tangent lines when the slope of the tangent line is equal to 0. And so we just simply set dy dx equal to 0. But that implies that minus 2x plus 10 over 2y minus 8 is equal to 0. And the only way that a fraction like this one is equal to 0 is if the top is equal to 0 but the bottom is not. So we just simply set the top equal to 0, and we solve this equation like so, and we get x is equal to 5. Now, if x is equal to 5, we need to find out what y is. And the way that we can do that is plugging it back into the original equation. So let's just go ahead and do that, and we'll put 5 in. So I'm going to carve out a little bit of space here to do that. Alright, so here we go. I'm going to put a 5 into the x squared here, up here. And when I do that, I get a 25 plus y squared minus, and then I put an x into here, and 5 times minus 10 is minus 50 minus 8y is equal to minus 25. Okay, so looks like we have a nice little quadratic equation here to solve. So let's just group our like terms. So let's see, we have 25 minus 50 is minus 25, but I'm going to add 25 to both sides, and if we do that, whoops, I forgot a y here, sorry about that. If we do that, we get 0, so we get that's not equal to 0, so we got rid of all these terms here. And so if I factor out a y, so when x is 5, we have y is 0, or when x is 5, y is 8. And I got that from solving this equation here, because this claims that y is 0, or y minus 8 equals 0, so y is equal to 8. Alright, so next we're going to have to find where we took care of the horizontal tangent lines, and I'm just going to check something. If I let y equal 0, I get a minus 8, and if I let y equal 8, I get 8, so I don't divide by 0 here. Okay, so that should work. Alright, so this is where we have horizontal tangent lines. Okay, the next part of the question asks to find vertical tangent lines, and that's where the slope is undefined. Alright, so let's set up that part of the problem. And I'll do that, I'm going to do that on the next page. Now we're going to find where we have vertical tangent lines. So that's where the slope is undefined. Okay, so that means that 2y minus 8 is equal to 0, but the numerator is not equal to 0, so we're dividing by 0 here when we find this this y. So that's pretty easy to solve. We get 2y is equal to 8, so y is equal to 4. Okay, so when y is equal to 4, I'm going to plug that back into this equation. So let's see, when y is equal to 4, that's what I meant to do. We have x squared plus 16 minus 10x minus 32 equals minus 25. I think I could fit in there. Okay, so let's see. Yes, if I put a 4 in here, I get 16. I put a 4 in there, I get 8 times minus 4 is minus 32. Okay, let's clean this up a little bit. So I have x squared minus 10x. Then I have, let's see, 16 minus 32 is minus 16, plus 25 is, well, let's do it this way. Let's add 25 to both sides. All right, so when we do that, we have plus 9 is equal to 0. And this trinomial factors into x minus 9 and x minus 1. So my two solutions are x equals 1 and x equals 9. So, so the points where we have the slope undefined are when x is 1, y is 4, and when x is 9, y is 4. So we expected 2 points of where we have horizontal tangents and 2 points where we have vertical tangents. And the reason why is, you know, if you look at a circle, then you have 2 horizontal tangent lines. and two vertical tangent lines, right there, and whoops, I missed, but right there, and right there. All right, good luck.